I got 8 people.
So, John.
Who said that?
Why is it 2 of you?
Oh, Ryan. Oh, yeah, I don't know. Oh, that's because I use my laptop microphone, but I use the software on my desktop. So, yeah. And I have like stuff on the side right here. All right, does everyone here have the software already installed? If you don't have it installed, you should install it right now if you want to follow along. And then, yeah, I have some slides here.
The UI is like, looks kind of simple for some reason.
Oh, did you open it up already?
Yes.
Oh, yeah, you're probably in like did you see this thing that says like, there's like some files on like the left-hand side?
What
Oh,
do you-
wait. Oh, wait, I think we'll go through it later. Don't worry.
Okay.
Yeah. Yeah, I think I'm just gonna wait till like 5:05, so in case anyone trickles in. But yeah, so just make sure you have like a mouse on hand and like the software installed if you want to follow along. All right, I think I'm gonna get started right now. So let me put these up. Yeah, so that link I posted is the like the slides I'll be using. So in case you want to follow along, you can just have those. All right. All right. So hi, my name is Jonathan. I'm a third year CSE major, and I'm one of the project leaders for IEEE. Today I'll be showing you how to design a PCB. Oh wait, let's see those. Oh yeah, Nate. I'm not sure really. I just use it. I don't really know too much about the behind the scenes of it. All right, yeah. So I'll be basically showing you how to for this workshop, we'll be basically going through how to design a PCB through the software, and then once you're done designing it, how to get it get it actually printed and receive it like mailed to you. All right. So there's many benefits of using a PCB. They're like you can like simplify your circuit. So like if you have it on a breadboard, it's usually pretty bulky and like pretty big. It takes a lot of space. But if you can like design your circuit and put into a PCB, you can make it like really like tight and like really like compact. So like imagine having to do like this kind of design on a breadboard. It'd just be like a mess of wires basically. So like the PCB allows you to like have some really complex circuits in like a nice form factor. And like another benefit is that like it's good for like say you want to like make multiple things of your design, you can just like have multiple PCBs and just like slap on your components every time you want to make something new. Yeah. So like this is like kind of like what you might see. So like say you like have like some breadboarded circuit that looks pretty messy like this. You can like design kind of like map it out in the schematic and then like make it more compact on like a PCB. So like these are some things people in our club have made. So the PCB is basically like the part right here, which is like the board basically that all the electrical components get soldered into. So like this is like a keypad. Uh, Someone made some like petter art with it because like you can do like all kinds of stuff. So you can do like art stuff too. This is like a micro mouse I made, um, and this is like it's like a breakout board for this cable because like I basically needed to access. This is like a ribbon cable that has like 28 lines in it, and I did basically needed to access the lines, so I made like a breakout board for it and hook it up to a microcontroller. But yeah, you can like mix a lot of cool stuff. Oh yeah, and if you guys have any questions about what I'm doing or if I'm going too fast, just feel free to like say something and then stop me. Okay, so today will be my goal is to like help you guys learn the software. So we're gonna be building something in the software. Um, I'll basically just be like building it, and then you guys can like follow along. I was like looking at it and like it might be a little too complex. So like you can try your best to follow along, but like if you guys can't, I'll just send the like my finished project at the end of the slides so that you guys can just like open up the thing if you want to learn from it. But yeah, so basically what we're going to be building is like a small keypad. So basically we're going to be using a microcontroller and we're putting some like keyboard switches on it. And we'll basically be seeing, let's see, just making like a little like keypad. So basically we'll be implementing this. If you guys know like what an Arduino Uno is, we'll be basically like taking like the functionality of it, but putting into like uh, a form factor that's more designed for our purposes. Because like, say if we're building a keypad with only 3 switches, right? we don't need all these like extra stuff around. We don't need these extra headers over here. We don't need like a lot of this, like these jacks, these regulators, and stuff like that. So we're literally just taking this chip and putting it on our board and designing everything around it. So before I do that, let me go over this real fast. All right. So basically we're using it's called the ATmega32U4. It's basically the same chip it's found on the Arduino Unos. It's really similar. Basically has the same functionality. So yeah, and basically this is a schematic of how to implement the chip. So like the chip is right here. You can see it's the ATmega32, and this kind of describes everything about it, all the pinouts, and it basically this schematic tells you basically where to put the capacitors, what values they need to be, and stuff like that. Yeah, so I'm basically kind of like just copying this for implementation. Okay, so I guess the first step is, yeah, so this is kind of an overview of how KiCad works. You basically first start with a schematic, which uses like our symbols, which is like the individual components. So like the microcontroller, the ATmega32 would have its own symbol. Every resistor would have their own symbols. Each capacitor would have their own symbols, and etc. Once you finish the schematic, each of the symbols get mapped to a footprint. And what the footprint is like how basically like how it's going to look on the PCB. So like, for example, right here, this thing is a footprint for like a button, I think. So yeah, and then this thing right here is probably a footprint for like a resistor or capacitor. So the goal is to like go from schematic, map symbols to footprints, and then go to the PCB layout. Yeah, okay, so we can start by opening up the software. Let's see. And then you probably won't have anything here if you just installed it. But what you want to do is go to File, New Project, and then just name it, just put it somewhere, and then just name it like anything. You can name it anything you want. Just call it like test. Oh wait, okay. I also saw some people joined. If you guys are like behind and just have any questions, just make sure you can like stop me and ask them. And if I'm going too fast, please let me know. Okay. So once you create the project, it'll give you a .sch file and then a .KiCad_PCB. For now, we'll be starting with the sch file, which is the schematic. So you can double click on it, and it should open up something like this.
It's saying I need to configure a symbol library table.
Oh yeah, just go like the default one, I think, to the one that's already highlighted. Did it work for you?
Yeah, it's good.
Okay, just checking. All right, so I can remember earlier. Let's see. Yeah, so like this is how we're implementing the microcontroller, and I'll go through it right now. So, all right, so to place a symbol, you start by clicking this icon right here in the corner, and then once you click, it'll like load in. It'll probably load in if it's your first time. It'll load in all the symbols, and then you'll get like this window here, and if you scroll down, there's like tons of stuff here, and like basically any like most electrical components you can think of, it probably has something related to it here. So since we know what I'll start with putting down the microcontroller, We know it's the at mega 32. So if I search it at mega,
Where do you click again?
oh, sorry. It's this. Do you guys see my mouse? Let's see. It's this button right here.
Okay.
Yeah. So there's like a text bar, so you can just look up one of the components. We're gonna be placing the microcontroller down right now, and if you just type in like AT mega 32U4, let's see. I use this option right here, the QFN44 package. Yeah, so then once you have it highlighted, you can click OK, and you'll basically get it on your cursor, and you can put it down somewhere. So put down here. All right, so the next step is to put down like, so we're gonna want like we're gonna need a bunch of resistors and capacitors, just like around the microcontroller, as in this, because like, it's like we need a 10K here, a 0.1 microfarad capacitor here, a bunch of caps here. So I'll just start by placing down some capacitors and resistors. So to get like a capacitor, you can like scroll down here and then find the like a capacitor. Or what you can do is you can just type a C, and then you can just get the unpolarized capacitor here. And that's how you can get the capacitor symbol and place it down here. To get a resistor, you can go into the symbol navigator and then press R, and then you can get a basic resistor like that. We're also going to be using like we'll be putting a micro USB port so that you can like connect to it with your computer. So another symbol, and we'll place like, you can search up like micro, I think it's USB. Yeah, USB underscore B micro, and then press OK and place it over here. So I'll start with placing all the capacitors, and you can basically like follow this guy and then like just place the capacitors down in like this fashion. So I'll start here. So there's a 10K on reset. To like, you basically need to draw wires. So we use this green wire over here, and you can like press on this like circle right here, and you'll see how there's like a wire on my mouse. And then I could connect it to this.
Do you right click the circle?
Oh no, you just so you make sure you're on the wire tool, and then just tap on the circle, and then move your cursor around, and you can move it right here, and it'll draw a bend for you, and you can click here, and then it'll be like connected. Yeah, and then this is connected to according to the schematic, this one, it's connected to the VCC right here, which is like which in our case, the VCC for this guy is 5 volts. So we need to get like a symbol for that. So to get like the power and the ground symbols, you have to click on this guy right here. So it's the one under the one we were using previously. So if you click on it and then just click anywhere, you can type like VCC, and then you can get the VCC icon, a VCC symbol right here. and click OK, and we can place it right there. All right. So next, oh, okay. And then another important thing we have to do is like, so for like future reference, say you look back at the schematic, I wouldn't know like what resistor value to use here, what we're using here. So like we want to put down like 10K since we're using a 10K resistor right there.
Wait, could you do that again?
Oh, sorry. Oh, you basically put your cursor on top of the icon and press E, and then it opens up the properties of the field, and then you can just type in like some numbers for yeah. So I put 10K, which basically means like 10,000 ohms. So
Do we have to click on the ground then click E?
no, you just put your cursor on top of the like the text field, which is right here, the one under it. And then you press E, like while your cursor's on top of it. Does that work for you?
Yeah.
All right, sounds good. Let's see. So next we have to add like a crystal oscillator, which is basically provides the microcontroller with a clock to run on. So we're gonna go here, we're going to the symbol tool, click down, and then we're searching for crystal. This one works. So let's see. The crystal gets hooked up to the XTAL1 and XTAL1, just crystal 1, crystal 2 pins. So we put it right here. We can put it like around here. And then we can draw some lines. So we can draw some wires connecting them, one end to one end, another end, another end. And then we want to make sure we want to label, like the 10K resistor, we want to label what frequency our crystal is running at. So this one is going to be a 16 megahertz crystal. And basically like all I'm really doing is like how I knew it was 16 megahertz. Well, I only knew because I'm copying this. I'm just following the implementation on this schematic over here. So like someone basically already did the work. They kind of they already drew out like how to implement the chip properly. And I'm just following it. So like right here on the crystal 1 and crystal 2, there's a 16 megahertz crystal right here. So that's just how I knew. And then next we'll add these like capacitors right here. So we're gonna toss some more capacitors down, using the symbol tool. Capacitors are C. So some useful commands you can use while
Wait, capacitor?
yeah, capacitor.
I'm getting like switched capacitor voltage converters.
Oh,
Oh, it's just
wait.
C, right? I think
Yeah,
I
it's
have to
just
scroll
C.
down.
Yeah, just type C, and there should be the first one. Okay, wait. Let me make sure.
Is it case sensitive for the megahertz?
No, yeah. So basically, this field right here doesn't really. It's just kind of like it's just like a text field, so it doesn't really matter. But I think I think it's capital MH and then a Z. Yeah, it's capital MH.
That's what I'm saying. So is it case sensitive then? Or is this just a reference?
It's just a reference. It doesn't
Okay.
matter. Just for like what you want to see. Yeah. Oops. All right. So yeah, we'll add some capacitors here. So some useful keyboard like shortcuts are, so like if you wanted to like move this one, you could go like, you could right click it and then click on the move button. But I think that's really like, it's kind of like a lot of work. So you can just like put your cursor on it and then press M, and then it'll automatically like go into move mode for you. And then say you want to like copy this capacitor instead of like adding a new like symbol each time, you could just put your cursor on top of it and then press C, which makes a duplicate. So I can just press C on all these and just make a bunch. And then if I don't want, I can delete them by pressing delete on top of them. And then one of the other ones is there's also a rotate command. Let me see. I think rotate is you just put your cursor on top of the symbol and then you press R and then it'll rotate it for you. All right. Is everyone up to speed or am I going too fast? Oh, wait. Oh, sorry. I didn't see the chat. Sorry. Okay, wait. Oh, Alan's answering them for me. All right. All right, yeah. So we'll just put some capacitors here. Let's see. Okay. You can like feel free. Like you don't have to put them in the same places. Just make sure the wiring is similar. That's the most important part. And then we'll label these as, let's see. So those are 22 PF. And again, to edit the fields, you can just put your cursor on the field and press E, and then you can type in what you want to say. Okay, if we go back to the schematic, you can see that at the end, they're connected to the ground. They're connected to the ground at the end of this. So we need to place a ground symbol here. To get the ground symbol, it's under the power port tool over here. So we have to click on this, click anywhere, and then we'll type GND for ground, and we can get the symbol here, like this.
What did you write for the text for the capacitors?
Oh, I just did 22 PF.
How do you edit the text again? Is it E?
Yeah, so you put your cursor on top of the text and press E. Make sure you do it on the one, you don't do it on the one with the question mark, do it on the one under it.
I think you also have to choose the selection button to do E. Like if you're on the wire button and you press E on it, it doesn't do anything.
Wait, really?
At least that's what I'm on. I had to switch to the selection tool. And then
Oh,
I don't know.
It looks like you can be on any tool and still be able to do it.
all right, maybe.
Okay, now it's letting me. I don't know. Maybe I was on some random selection. I don't know.
Oh, you can double click too. Oh, you can also double click. Yeah, there's lots of ways to do it. And if you could also probably right click it and then press edit value too. Yeah, like whatever you want. All right, so we got the crystal down, got this down. Let's see. All right, we can start, okay, so on a ref, there's supposed to be a 0.1 microfarad capacitor. So let's go that here. So we'll get another capacitor. I'll just copy it from here by pressing C. So it's easier. I'll put it like here, and I'll draw the wire connecting it like this. All right. And then on the other end, we'll connect it to ground. So what I can do is I can just take it, use the same symbol as over here, and just press C on it. Or see. Maybe it doesn't work. Duplicate there. And then put over there. I could have also just got it from over here again too. That. We'll add another capacitor. We need another capacitor. Oh, also make sure we label this one 0.1. So it's 0.1 UF, like that. And then on the UCAP.
Dạ, dạ cảm ơn bà.
All right. So on the UCAP pin, we have to add another capacitor. This one's a 1 UF capacitor this time. So I'll do a wire. I just copy the capacitor from here, place it here.
How do you copy the capacitor?
So put your cursor. So like basically put your cursor on top of the symbol you want to copy, and then just press C, and then it should like.
It's not letting me do that. I'm on the wire tool, and then like when I clicked, oh, it's kind of weird because sometimes you're on the wire tool and it lets you do stuff like that, but then sometimes you have to like click on wire again, then press C.
Oh
So
wait,
it's not consistent.
are you in the wire drawing mode? Like say you're drawing say like I'm on the wire tool right now, right? But I'm drawing a wire. Like yeah. So like that won't work. So you have to like press I think you have to like press escape, and that'll exit your.
Okay, yeah. I press escape and it changes to like a little mouse. Okay.
Yeah, you can't be drawing the wire and trying to pick up stuff. Yeah.
Well, when you press escape, it just goes back to the mouse tool. It's not still on the wire tool. So.
Okay. Yeah.
Yeah.
Yeah. All right, so we'll be placing another ground. So place ground here. Okay, so next, I think that's. Oh, okay, and then these two pins down here, these two need to be connected to a ground. So we'll just connect these together, and then we'll connect these to a ground symbol. This. Let me think. And then pin 33 also needs to be connected to a ground too. So we can just do something like this. Now we'll handle the power lines for the chip. So let's see. These are connected to each other, and these get connected to the VCC. So we can go the symbol or this one, click, get a VCC symbol, that. All right. So now we'll start doing stuff on the USB end. So we basically have a USB port that this guy is basically it'll provide power, and it'll provide we'll be able to transfer data from the microcontroller to our computer with this. So let me. Basically, this pin right here connects the power line from the USB. So this will eventually get connected to our VCC because this is what will be supplying our 5 volts to everything. I'm gonna call this one. Oh, okay. So there's another tool here which is pretty useful. Is that say I had to connect something say this D plus right here, this D plus eventually gets connected to this D plus right over here on the microcontroller. But having to draw a wire all the way through your schematic like this is pretty messy. So there's this tool, it's called the it's called like a label. So it's this one right here. And what you can do is like place a label on here, right? So you can name it like, I can name it like D plus, because it's like the D plus pin. And then I can draw the same label over here and place a D plus label over here like this. And basically this represents the same thing as drawing a wire from here to there. So these two are basically connected now. And like the name doesn't matter, just as long as they're consistent. So I can name it like test 1. And then if I name this one test 1, this basically has the same functionality as naming it D plus and D plus. So like you can name them whatever, just make sure they're the same if you want them to connect. But I'll just put this back to D1 for like, so because like so it's easy to read. Oops. And then we're gonna add a D minus 1 too here. That. All right, so that looks good. Okay, so now we're gonna be, well, we're working on the part of the circuit that basically it'll connect the voltage from the USB cable to the voltage from this VCC line. So basically connecting the voltage from the computer to power the microcontroller. But we need like some circuitry in between to like provide protection and just like make sure the power is smooth. So let's start this. So we're going to use something called a fuse. Let's see. We use something called a polyfuse, right? Like this guy right here. It's basically like a resettable fuse that like if the current gets like past a certain threshold, then like it'll trip and it'll like stop drawing current. So this helps protect the USB port on your computer, because I think a lot of USB ports on our laptops are rated for 500 milliamps. So we have to make sure we make sure we don't draw above that on our microcontroller. So we can place a polyfuse right here, around here. And then in the text field, we can just modify it to say 500 milliamps to say we want a 500 milliamp fuse. And then we also want to add some capacitors on our power line to like smoothen out the power. So I'll just go ahead and do that. I think the values I used were like 10 microfarads, 1 UF, and then 0.1. So yeah, so that's basically like what they used here. Yeah, all right. And then the other ends of the capacitors get connected to ground. Okay, and then so this V bus right here, this gets, oops. We're gonna be wanting to draw like a wire from here to the fuse to the V bus here. So basically this is a USB port right here, and our computer the 5-volt line from our computer will be connected to here. So we'll go through here. There'll be a fuse here to make sure that the current draw on that line doesn't go above 500 milliamps. It'll have these capacitors here to help smooth out the power. And then over here, right, we're gonna want to hook this up to the VCC lines, all these lines here, which will provide the chip power. So we want to get a power symbol here, like that. Does anyone have questions? Or is everything fine right now? Am I going too fast or slow?
Maybe just a tad fast.
Just a tad fast. Okay, I can like slow it down. Actually, yeah. So actually, if you guys can't keep up and just like, yeah, because I'm going kind of slow. I mean, like I think it's supposed to end at 6:30. Let's see, it's 5:40 right now. Yeah, but like, if you guys like get like lost or anything, you can. I'll link you guys the project files I do. So like, you guys can just download it and look at it yourselves. So it's just mainly to like, if you can just get familiar with the software now, it's fine because I'll just give you all this later if you want. Oh. Yeah. Okay. So now we're almost done. So I'm gonna just go over we got to add our switches now. So we're gonna be using something called a switch matrix. It sounds complex, but it's not too bad. But basically, we're gonna get our buttons. So I'm gonna I think a switch is like, if you type SW means switch, and then you do underscore push. Oh yeah, so SW underscore push is just like a generic push button switch symbol. So we're going to be using that. I'll place it here. Yeah. And then we have on our board, we'll have like 3 of them. So I can copy it 3 times like this. And then you see on one end, they'll all get connected like this. They'll all get connected. And then the other ends will get connected here. So basically, we want to be able to read these switch states with the microcontroller, right? So if this guy is pushed, we want to be able to read it on the microcontroller. So we're going to eventually have to hook them up to some of the pins. Yeah, okay. So let's see. So if you guys seen like the Arduino Unos, like this. If you were to hook up a button to one of these guys, you'd hook it up to like these digital GPIO pins right here, right? So these GPIO pins are essentially hooked up to like one of the small pins on the microcontroller. So if we go over here to the @mega 32U4 data sheet, if we search for a pinout for the @mega 32, we can go to images. Let's see. This one probably works. So this is kind of like a pinout. So all we need really to read a switch, to read like a button state is just a simple digital pin. So there's tons of digital pins here. I think it's just any of the ones that are, I think just these gray ones I think are fine. Yeah, or these yellow ones. So I think I'll be using like PD4. It's like, yeah. Yeah, PD4 works. All these work. So like you can hook them up here. So I'll place one of these labels here. I'll call it like column 1. Column 1, and then we'll call this guy out here column 1. So I just put down these labels, and what that essentially does is it draws a wire between this end right here. It connects it to this pin on the microcontroller.
How did you move around the board like that instead of just like zooming around?
Like panning. It's
Yeah.
it's the middle. It's your mouse. It's
Okay,
the
middle
scroll
mouse.
button click.
Okay.
Yeah,
Cool.
and then and then I'll put labels here for column 2, and then column 3. And then oh yeah, I forgot. Also, I need to put. I'll call this one row 1. Or sorry, row 1. So I need to add row 1 and column 2 and column 3 here. Yeah, so basically this is like, if you guys hooked up a button to the Arduino, this is like a similar thing. My 3rd year? Yeah, I'm a 3rd year. Oh. Okay, so I think for the most part we're done with this circuit, this schematic portion of it. Let me go back to my slides. All right. Did that. Okay, so now we're gonna start getting into the, like, in this thing, we're gonna start mapping our symbols to footprints, and then we'll go to the PCB portion after. But right now in the mapping portion. So, but to understand how to like correctly map this stuff, we need to learn about these different kind of like, they're called packages, and they're basically like the kind of sizing standards for like resistors and like these ICs. So like, for example, I don't know if you remember earlier, but like we chose the QFN version of the Atmega 32. So it'll look something like, it'll be like this package here. And there's also like, I know for this chip, there's also a QFP version, I think. Yeah. And then for all our resistors and capacitors, we'll also be choosing like some different sizing for them. So like, yeah, so this is like a kind of like a sizing. So from my experience, these are like the size of resistors you can pick. Normally I go with like 1206, because like this is pretty small, and like if you're trying to hand solder anything smaller than this, it's gonna give you like a headache unless you're really good. So yeah, I usually go like 1206 size stuff is good for S&D resistors. Let's see. Yeah, there's basically a lot. There's kind of a lot to take in, because like there's tons of different packages, but like once you start like looking at them, you'll get familiar with them, and then it'll be a lot easier. But yeah, I'll try to, hopefully that helps. So basically, we have to go to the mapping portion right now. So that's this button right here. It's right next to this ladybug, to the right of the ladybug. I'll click on it, and then it's going to ask you to annotate your schematic, and then you can just press annotate, and it'll just do everything for you, and it'll load all the footprints.
Wait, it's saying you have to run CVPCB for the first time or something?
What does that mean? Wait, what
Oh,
is
I think it was like a little warning, and then I clicked OK, and it's still doing what I think it's doing for you right now, I think.
Okay, yeah, that's fine.
Because sometimes, yeah, I clicked the button and it gave me like a dialogue warning, and then it it continued or something.
Okay. Yeah, if it's your first time loading the footprints in right now, it'll take a while, I think. Let me know if it's not done for you guys. But I'll just wait.
Finished.
Okay, cool. Can you guys see my screen right now? Okay. So as you can see here, there's like these are all our components we added. So there's our 10 UF capacitor. All the capacitors are here. They're labeled like C. And then we have a resistor here. We have all our push buttons here. Our crystal is here. And you can see already right here, our at-mega chip, the microcontroller, is already assigned to a footprint already. That's because like we chose the symbol, and like so like some of the symbols are already mapped by default to help make it simpler for you. But like they don't map the capacitors for you because like there's tons of like they don't know which capacitors we want beforehand. So like because like for the capacitor, I could have chose one that's like a 0402 size. I could have chose one that's a 1206 size. So like they don't know. But like for our at-mega chip, there's only one size. So that's why they kind of already mapped it out to a footprint already. So for these capacitors, you can basically go to like there's this on the left side, there's all the libraries. So if you look, there's one called capacitor underscore SMD, and there's one called capacitor underscore THT. So those provide like the through hole components and SMD components. And the difference between through hole and SMD is one actually like has wires that go through the board.
How did you do that? How did you just open up the
sorry.
model?
All right, so if you want to open up the model, this is useful for like viewing it. You basically click on the library, and then all the footprints will show up on the right side. And then you can click on the footprint, and then there's this button right here. It's next to the cog. And then you can click view selected footprint. So that'll show you this footprint. And then if you want to get a 3D view of it, you click this 3D display button right here. So like, if you kind of like want to see, this is an SMD component because there's like no wires that go through, and it's just like.
Whoa, that's so cool. Sorry about that.
Yeah, no worry. Yeah, it's pretty cool. It's kind of really nice for like visualizing what it looks like, because I know that can be hard if you can't see it. So yeah, we can just select some random ones for this. So I'll go with some through hole capacitors. And as you can see, there's tons of through hole capacitors here. It kind of all depends on like what size you want and like what size you can get this at. So like for a 10 UF capacitor, you probably like go on DigiKey and then like type in 10 UF capacitor, and then you'll see what they have. And then based on what they have, you'll choose one of these that's the correct size. But I'm not going to look for each one of these right now. So I'm going to just like select a random one. That'll probably be okay. Yeah, so I'll just go with, I'm just going to put down the number 63 right here. Yeah. And then you basically, to map it, you make sure that it's highlighted here on the one you want to map, and then you double click on the footprint you want to map to it. So if I double click, it fills it in and it automatically jumps to the next one. So if I want the same one again, I'll just double click again. I'll just keep double clicking. Yeah. And then, yeah. But say for example, some of these other resistors, I want to use an SMD version. I could go over to the SMD footprints and then click on like, I can find some of these. So like if I want like some of these standard sizes over here, like say I want a 1206 form factor, I can go over to the search bar right here. I can type in 1206, and then there'll be a footprint here for 1206 size, and there'll be a one for like a basic one, and there's one for hand soldering. I think the hand soldering version one is just like it has bigger
Wait,
pads.
when I put in 1206, it's not really like shortening the list.
Oh wait, did you click on this button next to the search bar?
Now I got it. Okay.
Yeah, so the hand soldering, the one that says hand solder has like a bigger pad, which makes it easier to hand solder. So I'll probably just use this one for the rest of the capacitors. Okay, and then for the micro USB, or actually, sorry, for the fuse, I'm just go to the fuses library, and then I'll look for one. I think I'll just go with like, because since I don't really know what like parts I'm gonna, we don't really know what parts we're gonna use yet. We can't really like choose the exact right part, but I'll just choose. Let's see. I'll just choose like a 1206 one. So 1206 hand solder. And then for the resistor, should be a resistor. Yeah, so if you scroll down, there's a resistor SMD and resistor through hole library. So we can go on we can try putting a through hole one down. There's tons of sizes here, but you can like click on one of them. If you're curious on what they look like, you can click on it, view the footprint, and get a 3D model of it. So it looks something like this. And then like, as you can see here, if you like, once you have the footprint viewed here, you can do stuff like measure it. So to double check if you got the right one. So like for this one, you know that you can measure it here and know that, oh, this pin spacing is about 7.5 millimeters or something like that. Or like, yeah. So I just put this random one down, looks fine. For the switches, right? So like I said, we're using like keyboard switches. So what you can do is, I think you can go, you can search up Cherry and unselect the library button, the library filter right here. And then some switches here will pop up. And then we'll go with the top one. And then we'll fill it in for all of them. Was that clear to you guys, how I did that? I basically had to, there's these different filters here. So like, there's one that filters by the library, but like, I don't know which library these are in, the switches are in. So I just, right now I'm searching all the footprints right now. So that's why I unselected the library filter. Because if I had this guy on, then this guy just searches everything inside of this library I have selected. But so if I unselect this one, then it searches all the footprints I have, and then it'll eventually find it. So yeah. I also don't know where the micro USB is, so I'll just, in the search bar, I'll click micro. Sorry, it's laggy. MICRO. If you scroll down, you'll see some called like, there'll be like a micro USB connector. This. and then you can map it out. So like you can use one of these connectors. So say I don't know what it looks like, I'll just view it. I'll look at it and it says that looks fine. So I use this guy. And then the last thing is for the crystal. So I'll go into there should be a crystal library here somewhere. Oh yeah, so there's the crystal library. And I'll clear the search bar, and then I'll just choose like a random one. Let's see what this one looks like. Yeah, okay. Okay, so once we have all these mapped out, we can click OK, and then that'll basically finish that. Then the next step is to generate the net list. This is basically like a file that kind of maps out how everything is connected. So we click this.
Real quick, what was
yeah.
the name of the resistor that you used?
I forgot. I think I used a 1206.
1206 resistor.
Yeah,
And is it a through hole or a SMD?
I use okay. So when I say like 1206, it always means SMD because like these guys are not through hole because they don't have any like wires coming out of them, right?
Okay. The hand
So-
solder one for the resistor, right?
Yeah, it's okay if you don't get these because like I'll just send you these files right after. So like this is just mainly for you guys to like get comfortable with the software. You don't have to choose everything I chose. So as I said earlier, we have to generate a net list. It's this button right here. If you click on it, this window will pop up. You can just click generate net list, and then it'll ask you where do you want to save it and what to name it. I'll just call it test, or I'll just call it like test, I guess. And then click save. And then once you're done with that, I think we're all done with the schematic portion. So now we can go into
Save as?
just save.
Where did you click there?
This button, the netlist button right here. Generate netlist.
Then just click generate netlist again.
Yeah, and then click save. And then it'll make a file called test.net inside your project folder. I'll go to it right here. Let's see. Test. Yeah, see right here, there's something called test.net. So after that, we're basically done with our schematic, so we can close it out. Make sure we save our changes. And if we go to our KiCad window again, we can open up the PCB file right here. And then we'll get this window right here. So as you can see, it's kind of empty. What we need to do is we need to read in our net list file we just generated. And we do that by clicking on this load netlist button up here. It's like 2 to the left of the ladybug. So I'll click on this, click on the folder icon, and then I select our .NET file we generated. And then these defaults options should all be good. And then once we did that, we click the button that's called update PCB, I think. Yeah. And once you click update PCB, you should see like some symbols like appear. And then after that, you can click close. And then right now you can see that if you zoom out, you'll probably see that there's like a clump of symbols following your mouse. And you can just drop them in the middle of your design. Yeah, so before we go on with that, I have some like slides we should go over. So we did that. Okay, so this is basically the anatomy of a PCB. There's a couple layers that are important. Mainly there's a core, and then there's one copper layer like right here in this picture, and then there's another copper layer here. So there's two layers. This is like a 2-layer PCB, and then we got the solder mask layer up top right here, and on the bottom here. So in your KiCad, probably on the right side here, you'll see how there's all these layers. So the first one here is the front copper. Then there's the back copper because there's 2 layers of copper. The other important one is the F silk and B silk. And then edge cuts is also important. So these are probably the most important ones we'll be like doing some drawings on. The other ones you don't have to worry too much about for now. So the front copper layer is basically, this is like where all the wires are. So like if you've seen the actual PCB, you'll see that there's tons of wires like going in and out. So like you see these wires here, these are all drawn in the copper layer. And then these labelings, these white texts, these are all done on the front silk or the back silk based on which side it is. So
Wait, you're pointing at the mask, but you're saying the word silk.
oh no, the front silk is the white stuff. It's like the paint layer on top, the silk screen.
But the text is also white.
Yeah, that's because it's on the silk screen layer. Wait. Yeah. So like this, like the white text, all the white labeling here you see, that's all the silk screen layer. Does that make sense? And then like all these like connections under it, these are all done in the copper layer. Does that make sense?
Yeah.
So like the silk screens, the front and the back silk screen is like, say all your text you're gonna write to like, so like see how they label everything like this? That'll all be done in the front silk layer. I'll go over that here. So all right, so we have a clump of stuff here. As you can see, there's color boxes next to each of these layers, which they can help you see where everything is actually. So for example, you see how if you scroll into this guy, the AppMega chip right here, you can see there's a bunch of red on it. That's because
I don't have that for some reason.
Wait, you don't?
I don't see any red. Like I don't see a 45 G&D.
Wait. What does it look like for you?
It's just not there.
What's there for you? Is there anything there?
There's just no 45 G&D there.
Oh. Does it say like is there a chip here for you? Is there like
No, there's no chip.
Okay, Nick says he sees it. Does anyone else not see it? Oh wait, so back in the previous step, let me go back to it. Did you finish this portion of it, the mapping?
Yeah, I did.
Oh.
Wait, so I think no, I assigned the AT as a capacitor.
Oh yeah, I don't think you want to do.
How do I reassign it to be the AT?
Okay, yeah. So basically, go back into your mapping, and then you'll have to find the symbol for the @mega. So, it's basically. Let's see. I don't know how the best way to tell you this. It's a QF. If you type in if you unfilter it by light, if you just want to search everything, search up QFN-44. And then it's this one right here, if you can find it, the one on my screen.
QFN-44.
Yeah.
Which one? There's a lot of.
The one that says 1 EP 7x7 millimeters. P is the pitch is 0.5 millimeters.
Oh, so QFN45 1 EP 7x7 millimeters PO. There's no thermal bias, right?
Yeah, no.
Okay, I think I found it.
Okay, cool. Yeah, just double click it so it gets mapped to it, and then press OK, and then regenerate your net list. So like create a new net list and then reread it in, and then
okay.
When you reread it in, make sure you click the option that says update footprints, I think. Or actually what you can do is like, you can delete everything you have already and then just reread it in, if that makes sense. Let me go back here. Okay. All right, so we have our PCB, our footprints laid out here. So this red means that it's basically in the front copper layer. If it was, so for example, if it was green, then it would be in the back copper layer, because there's two copper layers on our boards, since we're dealing with 2-layer boards. And then basically the blue means it refers to this color right here, which is the silk screen. So like on top of our design, on top of our board, you'll see like this blue circle here. And one way to check it is that we go into the 3D viewer. So we can go to view and then click 3D viewer, and then it'll kind of like show this. And yeah, so the white is a silk screen. You can see our chip right here. There's all these resistors here. And yeah, not everything will have a 3D model, but like a lot of the stuff does.
Wait, how did you do that?
View and then 3D viewer.
Okay.
Yeah, like this. Yeah, so we probably won't get to fully mapping, like fully connecting everything together today, because it's kind of a lot actually now that I'm looking at it. But you can basically use the same keyboard commands as what we're using in the schematic to like move everything around. So like I can select this, press M on it, and then I can move the footprint around here. And then if I want to rotate it, I can press R, and I'll rotate it 90 degrees for me. Yeah, so what you want to do here is, you see all these lines here? These basically show things that need to be connected. So what you would want to do is you want to think about how everything is wired and then place components so that it makes wiring simple. So like, let's see here. So that's just, so I know this capacitor here, this is the 22 PF capacitor. I know which, this one connects near the clock, which is this component here. So I would like want to place these like kind of close to each other, because see the wire right here, these have to connect to each other. If I had to place it all the way over here, then I have to draw like some connection all the way here, which yeah, can be annoying. So yeah, you just want to start by like think about how everything is connected and place stuff that's closer, that need to be connected, place them closer to each other. And like, but like sometimes like designs don't allow you to do that. Like, but like it's just best to like try your best. So yeah. this part will usually take like a long time. So yeah, we probably can't finish it in our 15 minutes left. But
How did you move it around again?
oh, it's just you click on it and
M?
press M. Yeah, let's see. Yeah, so there's okay, so I'll go over how to start like connecting everything together. So there's this tool right here. It's called the trace tool or the route tracks. This basically lets you draw wires all around your design. So like you see that wire I just drew? It's this red thing. I just drew this randomly. It's not doing anything, but as you can see, it's in the front copper layer. And then now if I go to my 3D viewer, you can kind of see it right there in the front copper layer. So yeah. So yeah, we can start by drawing wires to connect things that need to be connected. So for example, I see this column thing, this column for the switch. This gets connected to this pin on the microcontroller, like right here. These rows right here, you can see how there's a line drawing these to get connected. So I can do this like this. And then this column this column 3 net right here gets connected to this pin on the microcontroller. So we can draw a line going here.
How do you know if we draw the red copper or the green copper?
Oh, so that's kind of up to you because it's like they do the same, but oh yeah, let me explain a little more about that. So there's 2 layers of copper that there's 2 layers you can draw on. It's the front copper and the back copper. Right now, this chip right here is only sitting on the front copper. So like these pads, you can only draw front copper, like you can only draw on front copper to connect them. See, if I swap to the back copper, thing, I can't draw. It won't let me draw like a track on that side. It'll automatically just switch to the red one. But what you can do is like, let's see. Oh, sorry. If you were to use, you basically, it's up to you. But what you want to do is you use like whatever is more convenient. So like, say I'm drawing on the red copper right here, right? But like, say let me try to find something that I can demonstrate. Okay, so see how this one, I need to connect it all the way to the microcontroller. But like, say I was trying to route it this way, right? And then, but like, I can't really go through this copper right here because there's all your red copper, right? So like what I could do now is like, if I want to cut through this, I could instead, oops, sorry. I could like draw like, if I could draw like a green line, like by selecting the back copper layer and then selecting the trace tool, like green lines can go through it because it's like, it's a totally different layer. So I could draw this, and then if I wanted to like go through it, thanks. Another tool that you need to know about is the via, which is like, it's basically a drill through the hole through the PCB, which connects, it basically goes through the front copper and it connects it to the back copper. So what this allows you to do is something like this. So see how this capacitor right here is connected on it only has pads on the front copper, right? But say I want to draw stuff on the back copper plane, I could place a via right here with this via tool right here. I would place like a via at the end of the trace. And then now here I can draw either like the green lines, or I could draw like red lines coming out of it. This is because there's a hole drilled. This literally means there's a hole drilled, so you can draw out from either layer. And then what this allows you to do is something like this. So let's see. I'll delete this, and then so say I'm continuing this line. I'm trying to get up to the microcontroller, but this one's blocking me. So what I could do is I could end it, and then I could place a via here, and then swap to the back copper layer, and then draw a line that just goes through these. And this one, and then put another via here, and then swap back to the front layer, and I could like finish off the job. That's how you can like use vias to like hop over stuff, basically. Was that clear, or is that a little confusing?
Made sense.
Nick asked, like, what button did you press to switch to copper layer?
Oh, let's see. Okay, so there's a cool shortcut. It's called V. Wait, hold on. Oops, sorry. When you're in the like the selection tool, you can press V to swap between the layers. And I think when you're also using the routing tool, you can press V to swap between which layer you're using. So like right now it's on the green. When I press V, it'll swap to the red. So that's useful. And then another useful thing is, say I'm drawing a trace. Say I'm in the middle of drawing a trace, right? And like this, when I want to place a via here, but I don't want to have to like click on the tool all the way over here. What you can do is you're in the middle of drawing mode, you can press V, and then you can click down, and it'll put like a via here for you, and it'll automatically switch to the other layer. So I can do this, and once I'm over, I can press V again, and it'll swap back for me, and then that does that. Yeah, so that's kind of the basic of tracing. You'd have to eventually do that for all of these over here. That makes sense. Like, for example, these if you want to know what they get connected, you can click on it, and then the yellow line will kind of guide you to where it'll get connected eventually, which is this guy, like that. Yeah, so tracing can take a while, and it's pretty tedious, but it can be pretty fun, like drawing these lines around and figuring out how to like the best way to place the components to make your tracing a lot easier. That's like a big, that takes like a lot of time to learn. But like the more you practice, the better you'll get. Another thing you can do is like, so if you see this right here, our USB port is this guy right here. It'll get soldered onto this pad. But say we wanted to put this USB port on the other side, there's a feature you can flip the footprint. So if I right click it, there's a flip button here. It basically flips it to the other side. And when I click on view and 3D viewer again, and you see it disappears. But that's because it's on the other side. It's right here, see? So that's pretty cool. So like, say one of these, say it's getting kind of cluttered on this side, or like, so like, say if I put this here, right? This capacitor here, this fuse and capacitor here. This right now, as it is, this wouldn't work because I'm going to be soldering a mechanical switch on top of this. So I can't have like a capacitor and fuse right here. See, if you look at this, like my switch is going to be on top of here, and so it'll get blocked. But what I could do is I could click on this, click on the footprint for the capacitor, and I could flip it to the other side. I could flip both of these, and then they disappeared on this side because they're now on the bottom side. And then now I can put my switch on without any interference. So yeah, you can like make your designs pretty compact. So like I could actually put my USB port on the other side now, like over here. Even though it's kind of like on top of the switch footprint, it's on the other side, so it doesn't really matter. Another important tool is the edge cuts. That's this layer right here. So you basically click on it to select it and make sure the blue arrow is pointing at it. And then there's this graphics lines tool right here. And then you use the edge cuts to specify like the shape of your PCB. So you can draw lines like this. It probably looks pretty messy, but you can just draw something enclosing your whole design. And then the important thing about the edge cuts tool is that like it has to be sealed. So like you have to make sure you go here and make sure it's like you get it like it's sealed properly. It's like this. And then now when I go into my 3D viewer, you'll see it looks like this jagged thing I drew out. So yeah, that's how you can like shape up your design and stuff like that. And then but what if say I want to check say I don't really know how big this actually is, right? Well, there's a tool here there's a dimensioning tool here. So I could, there's this measuring tool right here, which I can use to measure like the width. So I can click on one end and I can click here. So now I know it's about 75 millimeters wide. And then I can use that to like figure out like, oh, maybe do I need to make it smaller or do I have more space to work with now? So you can use the measuring tool to figure out your dimensions of your current PCB. Go back. 3D viewer. Okay. Yeah, so basically to finish this off, what I would have to do is just finish like drawing all these traces here like this, like that. Yeah, it's just basically a bunch. Yeah, I probably don't have time to do it now, but I did finish this. So like I did work on this like last night, and then I kind of like show you like what I did when I have more time. Let me find. Oops. How did you cut again? Oh, okay, yeah. So I selected the. Oops. So I selected the edge cut tool right here, and then I clicked on drawing add a graphic line, and then I basically draw lines around the whole thing like this, and then I make sure when I seal it off, it locks on, so it's a sealed shape, and then that'll work. Okay, yeah, but I'm gonna show you what I worked like, kind of like a finished product. Nice. This is the one that you guys can download if you guys like want to see it. So like this is something we can do, and I can view it right here. So basically, like I did like a better job. Obviously, I had more time. So you can see the microcontrollers here. There's like the pads for the capacitors. The capacitors here, everything like that. The switches go here, and then everything is traced out like this. So once you like kind of like finish your design like this, you can get it manufactured. So there's a few sites like some of the ones I've experienced with are JLC PCB, PCB way, and then OshPark. JLC PCB is nice because they price it based on like, as long as your design is under 100 by 100 millimeters, they'll give it to you for like $2, and then you probably pay like $20 for shipping, so it's like $22 in total. That's a pretty good price. OshPark, it's good for like, they charge based on square inches, so like area, so it can get expensive pretty fast, but it's good if your design is really small. Yeah, like these are kind of like the two options that I use. And basically, say I went to order a PCB from JLC PCB, I would just go to JLC PCB, click on here, click on a quote. So now it's asking for my Gerber files. Basically go here. So to generate those, I think each manufacturer has like their own instructions. So like, as you can see here, they have instructions. There's a link. I think they'll kind of go through how to generate the files here, but I kind of know how to already. So what you do is you can go to like File, Plots, and then you'd want to make a folder inside your project folder. So I could call it like Gerber's, and then click on the output directory, and then yeah, select the folder. And then I think these default settings are fine. When you go to like the site you're ordering it from, they'll have their own instructions, but for the most part, I think these are fine for now. And click plot. And then right after that, I have to click generate drill files. Yeah, these are all fine. And I click generate drill files. So that generates everything I need. I close it out, close this. I'll go to my Gerber's file folder. So it basically dumped all this stuff in here. So with those files, I can right click this. I'll compress it. I'll send it to a zip folder. And now I can upload it here. Okay, as you can see, it processed my thing, my files, and it kind of like came up with like a preview of what it's gonna look like. So it looked kind of right. So now I'm just gonna go in here, and these are like kind of some settings you can choose. So we chose a 2-layer board because we have 2 copper layers, so we chose 2-layer. These dimensions are auto-generated. You can choose your quantity. I just choose 5. I don't need that many. This should be on 1, delivery point 1. So this is your thickness of the PCB. You can like, if you say you want it to be thinner, you can choose like some thinner options. But like some of these can change the price basically. Because like say I choose a really thin one, it's going to charge me $48 compared to if I choose like a 1.2, it'll be like 18. Wait, yeah, 18. Well, let's see. So, yeah. So let's see. Why is the price so high? Oh, so here I think you choose like this surface finish. Like there's different surface finishes. I just use this one. It's the cheapest. Yeah. So now it's like it literally says $2 for my board. Oh, you can also choose your color. So like if you want to go like black, I know black looks really nice, but like it takes 2 days longer to make, so that's something to consider. But like there's different colors you can choose, and then for the copper weight, for the most part, you just keep all this stuff what it has. So yeah, once you're that's basically all the settings you would do. And then you can just click like save the cart and then go through with the purchasing and all that. Yeah, wait, let me go back. Oh yeah, so eventually you'll like order it and then you'll get it in the mail. And then then you can kind of like solder everything onto it. And then I think that's it. Oh, so I'll paste this link. This is basically all the files. This is basically the project that I just opened up. I just uploaded it. It's just this guy. So if you guys want to like look at it and like mess around with it, you can. All right. Ooh, wait, did you guys, that was a lot. Wait, do you guys have any questions? I think I lost like 50% of the people. Yeah, this is kind of too much content to go over in like one workshop, in my opinion. But hopefully you got like a general overview. If you guys want to get into it more, you probably definitely have to like look into it more yourself, because like definitely can't learn most of the stuff in an hour and a half. Like I think I forgot to go over like let's see. Oh wait, no, never mind. I didn't do the design rules. And then I didn't go over the DRC. But like I can just explain it real quick right now if you basically design rules is like these are all the specifications that you need to set beforehand so that you're like every manufacturer like JLC, PCB, Oshpark, PCBWay, they all have like their limits to how small they can make their traces, or like how small their vias can be, how big their vias can be. So let's so like for example here, right? So they have like minimum clearances. So like clearances between a via, clearances between like pads, stuff like that. So like in the KiCad, you can put settings so that like you make sure that your design fits within their capabilities, which basically allows you to like know that your design, what you're designing right now, is able to actually be manufactured. So yeah, so basically if you put like your limits correctly, KiCad will make sure that when you're drawing everything out, that like you won't draw pads too close to each other. See like here, JLC needs a minimum of 0.54 millimeters between vias. So yeah, those are what design constraints do, design rules. The other thing is the DRC. This basically helps you find like, say you're like, say you just finished like connecting everything together and you're like, oh, I'm about to finish with my PCB, I'm about to get it ordered. You can run the DRC, and what that'll check is like, it'll let you know if some stuff is too close. If say you forgot to connect something, it'll tell you. Say like something is overlapping. So for example, I go here. Say like I did this. Like this would probably like here. So I'll run it right now. There should be no errors. Yeah. So there's no problems right now. Like say I did this. I put this here. Like I just slapped it on top of this. And like if you look at it from a 3D point of view, you can see like that was kind of whack. Like like it's not gonna work. So what you can do is I'll run the DRC. Oh, and it'll like, so what it says basically is like, it basically says like these pads are too close because like, and then I'm literally like putting the pad on top of a drill hole, so it'll warn me about that. And I also get an unconnected warning because it was originally connected to here, and then I moved it, so now it's not connected. So this is how it alerts you if you missed any connections. So yeah, it's pretty useful for making your stuff is good. Let's see. Yeah, and then there's something. Oh, another thing is the ground plane. So you can see there's this like square right here, right? I'll just delete it so I can redo it. So like when I did this design, right, I purposely didn't connect all the grounds together, because usually what I do is we use a ground plane. I have a slide here. Oh, here. So the ground plane is like once we draw all the traces out, we just fill in the rest with a ground. This helps like reduce noise, and it'll connect all our ground stuff together. So as you can see, like for these guys, I didn't even connect ground to anything. Yeah, see, it's unconnected. Here's unconnected. So what I can do is go into this filled zone tool, and then let me draw some, like click first, and it'll ask me like, oh, what layer you want to do it in? And I'll just use the front layer, and then just draw, and then like that. And then what that does is, see, there's a setting where you can like see what's filled in. So like it basically filled in everything, but like it didn't fill in these traces here. So like it avoids these traces, but like anywhere where it can fill in, it fills it in with a ground. It's like this, all this metal stuff here is connected to ground. And then what that does is oh wait, hold on. This doesn't work, wait. Oh, it's because I didn't select the ground right here. So if I select this, and then at the, what's going on? Okay, I had to click ground right here, and I press OK. And then now if you check it out, you see how it automatically connects the grounds to this big piece right here. So like here is connected. These are connected, but you see this guy is not connected because it's not ground. So I'll do that, and then that can just handle a lot of the ground connections. Yeah. And if you look at here, yeah, you can see it. So like, for example, see all the stuff surrounding these traces. All this is like the ground plane. So that's kind of what it looks like. That's how come you can get like circuit boards that get that like that look to it. So yeah. See, if I look at the other side, it looks like this because there's no ground plane here, so it looks like the color looks a little different. I think that's everything. Does anyone have any questions or any feedback? Do I get paid for this? No, I don't get paid for this. Oh, really? No, I just do this for fun. No, it's because I'm like giving back, because like I actually learned this stuff for like, there's basically an IEEE workshop like when I was a freshman, so like 2 years ago. Yeah, about 2 years ago. And that's some guy, like he stood up there, he taught everything. And like, that's how I got into it. And then that's how I learned everything. Oh yeah. So I usually use DigiKey. And DigiKey is nice. There's also like Mauser too. So like for some generic components, I can also use Amazon. Like, so I just like want some like basic capacitors. Like Amazon usually sells like I think it sells like, yeah, just like they just sell like a shit ton of stuff. So like sometimes more better value to get stuff off like these generic components off Amazon. But like some like the specific SMD components, like say you want a resistor that's a certain size, then you would go on like DigiKey like this. And then say I go to resist like this, right? So then there's like these top categories, but say I specifically wanted the SMD one, I click here. And then here I would basically look through, I go like, okay, so I'm gonna go with like maybe like this 168 ohms, or like, hold on, I'll just go with something I know. Like, yeah, anything. And then I could filter it by, let's see. There's, oh, here, package/case. So there's here, like, say I wanted like 1206 or 1206 right here. And I click apply all. And then down here, it'll show me some resistors. It'll go like 25.5 ohms that are in the 1206 package. So like, that's what I can do. And click on it, and I'll add it to my cart, and everything like that. Do you use any software to verify? Wait, what do you mean by verify my service? Like verify it works properly? Normally what I do is I usually like, I'll breadboard it first. I basically like make a breadboard version, and then I kind of just copy it. But like, if it's something I've done before, like a dozen times, like hook up a switch to a microcontroller, then I'll just like do it because I know how to do it already. Or like, you can also like say you want to implement, like figure out how to wire something up. You can like probably like find someone else who's done it online, and then like people like do their own. They'll probably like have like a schematic up or something. So there's tons of online resources. Yeah. Wait, did I answer your question? I'm getting kind of like my brain is a little slow right now. All right. Yeah, if you guys need like any help with anything, yeah, just feel free to like DM me on Discord. I can help you with the project or something. Yeah. All right. I think that's it. I'll end the meeting right now. Thanks for coming out.